Hello, math students. We are going to move on a little bit with solving systems of equations by graphing. We're still going to be graphing two lines to see where they cross. I want to remind you that we have already done these problems where usually we get one solution. We get one spot where the two lines cross, and that's it. Sometimes we get no solutions. That's what happens if we have parallel lines. If they're parallel, they're never going to cross. Remember, every single point that you graph on a line is a solution for that equation. So if we can find the one point where they cross, then that one point would be a solution for both equations. That would be the solution for the system. If they don't cross, if they're parallel, we get no solutions. Or we can get infinitely many solutions. Now remember, that's the number of solutions we can get. Sorry for the bell. That's the number of solutions we can get. The solution that we would write would be all points on the line, because every point that's on one of the lines is also on the other line. So if I have these two equations, I would start by graphing that first equation. So y equals negative, let's put a 1 there, make it look like a fraction, negative 1 over 1x plus 1. So we would begin at positive 1. My slope is a negative 1, so down 1 and over 1. Get a whole bunch of points. I'm going to struggle a little bit drawing a nice straight line here because I can't use a straight edge, but you certainly can use a straight edge. The second line isn't in slope-intercept form. That's the thing that we're adding in today. So I would want to subtract this 1x, and I'll get that y equals negative 1x plus 3, or negative 1 over 1x plus 3, which means we begin at 3. That's our y-intercept. But this has exactly the same slope. That's what I'm hoping that you're starting to recognize. When we've got the same slope, the lines are moving the same way. They started at a different place on the y-axis, so they don't have the same y-intercept. But if they have the same slope, they will not have any points where they will share. So a negative 1 slope from there is going to give me this line that's parallel to what we started with. Since they don't share any points, and remember the solution is the point or points that they share, that's what we're going to use for our symbol. Remember, you can write out no solution if you want to, but that's faster. For this problem, my first equation begins at positive 4, and I have a 2 or 2 over 1 slope. So up 2 over 1, it's going to be a positive slope. I can also go down 2, which is negative, and left 1, which is negative, which gives me a positive slope as well. Now, my second equation, again, not in slope-intercept form. So let's start by moving the x to the other side. Let's add this 1x. So I would have 1/2 y equals 1x plus 2. But I don't want 1/2 y, I just want y. I would have to get rid of multiplying by a half, but we don't divide by fractions. We would multiply by the reciprocal, which is 2 over 1, or just 2. But everything gets multiplied by 2. So it's actually going to look like a distribution on the right side. This is going to give me 2x plus 4. It's exactly the same line, which means I would start at 4. I would have a slope of 2, up 2 over 1. I'll do my best to draw as close as I can to my original line. Every single point that's on the first line is also on the second line. This is where we have infinitely many solutions, but you can't just give me an infinity symbol, even though it's super cool. What we need to do here is say what the solutions are, and the solutions would be all points on the line. And if you remember, I did mention I'm okay with this. APOTL is all points on the line. You can use that with me. You cannot go to another math teacher and say, oh, that's APOTL, because they won't know what that means. You'd have to say all points on the line. For this problem, how can you tell if the solution will be no solution for a system of equations? We had one of those problems, right? It had the same slope, but it had different y-intercepts. So let's take a look at this one. The first equation is in slope-intercept form. Done, we're good, everybody's happy. In the second equation, we're going to have to distribute here. So I'll have 2x plus 3y plus 9 equals 3x plus 27 plus 2y. So I'm going to work a little bit of magic here and do kind of double steps in one. Let's move all the y's to the left side and all the x's to the right side. So we're going to get rid of this 2x. And we're going to get rid of this 2y. Actually, if you're brave enough, let's also get rid of this 9. So I'm going to have, that's gone, 3y minus 2y would just be 1y, or y. 3x minus 2x would be just 1x, or just x. And then 27 minus 9 would be 18. Looking at this without graphing it, I can see that the slope of this is 1, the slope of this is 1. And they have different y-intercepts, which means they would start at different places on the y-axis, but they have the same slope, so they're going to move the same way. This would be a no solution kind of a problem. That's what we're looking for. Yes, I still want you to graph those if I'm asking you to graph. This one I didn't. But I'm hoping that you're starting to recognize the same slope. That's a big deal. If it's the same slope and the same y-intercept, they're the same lines. If it's the same slope and different y-intercepts, those are going to be parallel lines. Okay, so this is what I was just saying. Tell me about the solutions if the graphs have different slopes. If they have different slopes, at some point those two lines are going to cross. So we would get one solution. If I have the same slope, but different y-intercepts. Same slope means they move the same, different y-intercepts means they start at different places. Those are going to be parallel, so there will be no solutions there. And for the last one, if they have the same slope and the same y-intercept, they are the same line. We will have infinitely many solutions. So again, without graphing, in number 1, they have the same slopes, but they have different y-intercepts. This will be no solution. Start with the slopes. Every single time, start with the slopes. Different slopes. They happen to have the same y-intercepts. I don't really care about that. What I care about is that they have different slopes. That means that they will cross. They would happen to cross at -3 on the y-axis. So this will have one solution. And again, it would happen to be at 0, -3. These two equations are the same. They're exactly the same. They are the same lines. There will be an infinite number of solutions. So the solutions would be all points on the line, but how many solutions there are? Infinitely many. Without even graphing this, I would hope that you could look at this and tell me that this is going to be a no solution. I'm going to graph it just really, really fast. I'm going to begin at -2. I've got a slope of 4. So here's my first line. Second line begins at +1. +4 slope also. No solution. These two clearly do not have the same slopes. These are going to cross. That first equation, when it's x equals -4, Remember, if there's only an x, if there isn't a y, it will not touch the y-axis. This is going to be a vertical line at -4. So here's my first line. The second line begins at 2. And I've got a 5/4 slope, but I don't have room to move up 5, so I'll have to move down 1, 2, 3, 4, 5, 1, 2, 3, 4. Right there's my point. Ooh, I missed a little bit, but that's okay. -4, -3 would be my solution. This one, clearly I'm giving you more difficult equations because I'm trying to hide something, right? In that first equation, let's get rid of the 36, and we're going to flip-flop sides. So I'll have -9y equals 6x minus 36. Divide, divide, divide. -2/3 x when I simplify that, and a +4. In my second equation, let's move my 3. So I'll really have -3y equals -1x minus 3. I was thinking of the wrong problem. I thought that I was going to have one that was the same equations, but they're not. So this will be a 1/3 slope plus 1. So my first equation begins at 4. I've got a -2/3 slope, so down 2/3. And that's really all I can technically get there. The second one begins at 1. And I've got a 1/3 slope, up 1/3. So that point is at 3, 2. Sometimes you are going to have to do a little bit more work to get the y by itself. In this problem, that 1/2, I know throws some people off, but remember, I'm just trying to get the y by itself. So I would start by, let me just rewrite the whole thing. Let's just get rid of that 1/2 x. And again, I'm going to flip-flop and put the -y first. -1/2 x plus 3. And then I don't want a -y. That's really a -1. I'm going to divide everything by -1. I know it looks weird to have the fraction there being divided, but they're the same signs. I'm just going to get a positive now, 1/2 x minus 3. So I begin at -3, positive 1/2 slope. For my second equation, I would add this 1x. So I would have 2y, putting that first, 1x minus 6, divide, divide, divide. It's exactly the same. If I would graph this line, even though I didn't do a very good job of graphing it the first time, I would have exactly the same line. I would have exactly the same points. This is infinitely many solutions, but the solutions are all points on the line. Okay. I haven't decided yet if I'm going to keep a question like this in the test, but I do usually have a question like this on my systems test. If I give you an equation, any equation, can you write another equation so that I would get one solution? If I want one solution, basically all I have to do is just change the slope. I don't care what your slope is, it just can't be 2. So I could just say y equals x minus 1. I didn't ask what the solution is, I just wanted 1 point for my solution. If I want no solution, that means it has to be parallel. Same slope, different y-intercepts. So y equals 2x, and then just not minus 1. I could just stop right there, y equals 2x. We'd have a different y-intercept. You could pick a different number if you wanted to. Add a million to the end of it. They'll be parallel. Infinitely many solutions means exactly the same equation. So today's worksheet is a riddle, kind of puzzle worksheet. It's a riddle about eggs and sticks. The answer key is in Schoology. Make sure that you do the learning check when you're all done and let me know if you need any help.